Great. Welcome back and welcome to our panel discussion. So on our panel, if you've been with us the whole day, you've seen the speakers, but just to reintroduce them in case you've come in just for the panel discussion, we've got Dr. Raoul-Gabriel Urma from CEO Cambridge Spark. We've got Professor Alessio Lomuscio from Department of Computing at Imperial College London. We have Rob Claxton, who's a BT Senior Manager for Big Data Insight and Analytics, and Dr. Detlef Nauck, who's the head of AI and data science research at BT and a visiting professor at Bournemouth University. So I've got a series of questions here, guys, that's come from our live audience, which is kind of cool to have in here, as well as online as well. And what I want to do, Detlef, I'll start with you first about, there was a lot of discussion about wrongness in the data models. So how much wrongness can we tolerate in our models? And is there an optimum balance of wrongness?
Okay, I mean, wrongness in models, ideally you want to have none, but you will always have some because the models that you build are essentially statistical models. That means they can't be 100% correct. And you have heard Alessio talking about how well a model performs. You have Rob heard talking about it. And the important thing is to test and to be aware of how well a model actually performs. And then if it doesn't perform to the level that we're expecting, trying to figure out why that is. And that very often can be traced back to the data. So that there are issues in the data that you have overlooked. And Michael had some examples like artifacts in the data that you weren't aware of that your model has picked up instead of what you expected to pick up.
Cool, great. Alessio, is there anything you want to add to that in terms of the wrongness about data models?
No, I think I agree with Detlef. I mean, I would emphasize that it's important to know how wrong things are and where problems may arise. I think what's important that we shouldn't be flying blind, but we should be aware of where we're reaching an envelope, either at runtime or at design time, where the envelope is, where things may go wrong, and take precautionary steps when we're approaching that area. I think it's inevitable that these models will have fragility, but understanding where those fragilities are is very, very important.
Okay, great. And Rob, just kind of building on that, I mean, you mentioned about having a kind of a predetermined view of what your model should look like, what good really look like. But so how do you determine up front what good looks like when you're actually looking to build models?
So I think you have to understand what it is that it's going to take for a model to actually be useful. So I think having a very clear-eyed view about how the model is actually going to be deployed and make sure that it is actually capable of delivering a benefit. And that's what that upfront assessment that I proposed was all about. It's just the beginning of trying to get a handle on that. It doesn't resolve the question, but it gives you some constraints and a framework to aim for, and you can start to reason then about is this a leap too far? Am I going to have to create a state-of-the-art model or something beyond state-of-the-art for it to actually create some sort of business benefit? But really, it all begins with understanding, I think, making sure you understand how the model is actually going to be deployed and what it takes for it to actually be useful in the real world.
Okay, great. Thanks for that. And Raoul, do you have a comment?
Yeah, I think I'm going to be a bit more controversial. Sorry, Alessio, I hope that's okay. I think models can be wrong, absolutely. And I think it's important to think about the business impact and the business outcome in the first place, right? So if the model that does face recognition on my phone gets it wrong, it's not the end of the world. I'll just enter my passcode because actually there's a cheap alternative available, and a wrong prediction has very much zero business impact except a slight inconvenience to the user. So when we talk about models being right and wrong, I think there's the scientific approach of that definition. There's probably also the business outcome that we want to think of. So of course, a misprediction for a critical path for a rocket going to space, that would be a huge deal. So we want to make sure that this is absolutely correct because there isn't an alternative. And if we fail, it's really, really expensive. So maybe we should caveat, I think, right and wrong, and maybe a sort of business outcomes and what's a cheap alternative available if there is one. So I just thought I'd provide a different answer in the mix.
Okay. Detlef, you want to?
Could I respond to that, given Raoul has disagreed with me?
That's the whole point of a panel discussion, Alessio.
Could I just respond to that?
Yeah, I think that Detlef's got a comment. If you want, then Alessio, I can come back to you. Yeah.
Thank you. I just want to say that I don't think I disagree with Raoul at all. I think that's spot on. If we're building a Formula One car, for example, we're going for performance, and we don't really care much about the robustness beyond the race distance, right? If I'm buying a car for traveling somewhere, I want a car to be robust. I don't care too much about the performance. So it's absolutely essential. Like Rob has said, it depends on what that model is meant to do. If I'm typing in on my keyboard picture of a cat, I don't really mind if a dog comes out. If I'm driving a car and it's not detecting a fire engine, then I do care. So it's all about what that thing is supposed to do.
Okay, great. And Detlef, do you want to make a comment?
Just because Raoul mentioned image recognition, facial image recognition, there's also the question, a model that can be performing really well might be consistently wrong for a minority of users. And that's the issue of biased models. And we know this in facial image recognition, for example, where these models are typically gender and race biased. And so you can have this effect that a model on a high level looks like it's performing well, but it consistently underperforms for a certain type of input or a certain type of user. And that's something that's very important and needs to be addressed.
Yeah, I think what we're actually, between us, all saying is relatively consistent. I think the question of how wrong can a model be, one angle on that is the model useful, right? So we can tolerate it not being perfect, but is it useful in the business context? And then the other angle, which you're starting to touch on here, is it safe? And that question obviously depends very much on the context that the model's in. Some applications are very benign, and we can tolerate quite kind of gross errors in many cases, and others aren't. And when it comes to safety, I think the key there is to not be fooled by what you've got in front of you, that you've actually been a bit skeptical when you're going through the process of building the model, and you've kind of done the best you can to tease out what the different failure modes might be, whether they're things like bias or fairness, or as Michael was talking about earlier, models that go and cheat. So they make you think they're doing a really good job, but maybe the reason that they're performing highly depends on something in the environment that changes later, or you move them into a different context and suddenly it falls apart. You've got a disaster on your hands. So I think it's obvious really, but it very much depends on the context that you ask that question in. How wrong can the model be?
Okay. Great. For me, it's quite fascinating that you may have a wrong model, or even in some cases, wrong data, and it's, although it may not be the ultimate outcome, it's kind of it's not a disaster. Once again, subject to how you're using it, the context and the application. But one of the other questions was about so you've got a wrong model, or you may have wrong data. So how do you actually still use that in terms of moving your program or your project forward? I mean, I know there were some discussions around it, but I want to explore about, okay, you got all this wrongness. How do you still move your project forward? And Raoul, I think I'll come to you first with this one.
So let me just rephrase the question if I understand. So we build a model on some data. So maybe a recommendation engine for Amazon, and this model is not making the most optimal recommendations to impact revenue. And we kind of figured actually it's not doing the right thing. What do we do with that, right? So in terms of pushing our project forward. So I think there's a couple of things. So one is we clearly have established a benchmark. So I think that gives us a North Star to aim for. We can use that to do what's called regression testing. So if we are to push improvements, can we benchmark whether it's doing better or it's doing worse? So having that baseline, I think, is great to drive a project forward. I think through a bit of analysis of the model and the input data, we can try and figure out what maybe certain features picking up on, and that can help guide the debugging, that can help guide the data science team to make improvements that might even guide us to kind of go back to the data and see actually where there's some issues there in the first place. So I think we can definitely learn from failures, right? I think there are two things here. One is having a baseline to understand iteratively are we improving or not. Two, helping the debugging process.
Great, thanks, Raoul. Alessio, do you want to add to that comments from Raoul?
No, I agree with everything Raoul has said. I mean, we have a bunch of techniques that we can use to improve on things when we detect that are not in line with what we would expect. I would just add that sometimes we may not have to do anything, in the sense that sometimes we may be reassured that we analyze the system and we understand that either the probability of a mistake is so small that we're happy to tolerate it, or the cost of a change is just too high with respect to the potential gain. I just want to bring up that we use computer systems all the time for which we know there are bugs, and for which we actually sometimes know where the bugs are and how to fix them. And sometimes we just don't do that because it's just not worth it, frankly. And actually changing things may be more risky than living with the bug that you know it exists. And by the way, this also happens in safety critical systems, and where the cost of a change or the risk of implementing a change may be greater than the potential benefit. Again, I go back to the previous answer. I think it's all about understanding and have a reasonable understanding what the specifications are and what the system is doing.
Okay, great. Detlef, Rob, do you want to add to that?
Yeah, just to provide a slightly different slant on it, really. I mean, we learn by making mistakes, don't we? So it's okay to make mistakes, but I think the crucial thing is you don't keep making the same mistakes, and the way you avoid doing that is by keeping a record and having infrastructure, tools, substrates that you can learn on. And I think my view is big organizations often have a really terrible memory. They're not actually very good at doing that, and particularly when you've got data science and AI activities being conducted in perhaps little teams that maybe don't talk to each other. So I think the question becomes one of how you can promote kind of learning across the organization and make sure you remember the mistakes, that they're documented in such a way that they're available to people to actually learn from. And that means putting in place some kind of disciplined processes and some infrastructure that will actually support the memory of those mistakes.
Yep.
Okay, so let me ask you kind of a question. And once again, it's kind of adjacent to this, and it's about it was referred to me as dynamic models. So you start collecting your data, building your model. You kind of know what good looks like. You got all your ducks in a row, so to speak, and then the environment changes or the market changes or whatever. How do you deal with that? You can maybe be a couple of years down the line in terms of your research or whatever it is, and then everything changes. How do you deal with those kinds of dynamics in terms of your data models? So, Detlef, can I start with you on that one?
Sure. I mean, that's something Rob touched on in his presentation, right? So you need to monitor the performance of your models. You need to understand, are they still doing what they're supposed to be doing? And if something changes, then that could have a number of reasons. So maybe the data that you feed into your model has changed somehow. It could be that the way you collect the data has changed, or the way people behave, and that is reflected in the data has changed. And then you need to think how you mitigate it against this. So you can either rebuild your model to adapt it to the changing circumstances, you can clean up your data, or you may have to realize that maybe you can't improve the model anymore, and it is stuck where it is. And like Alessio said, it might be okay to continue using it. You just need to be aware that it doesn't give you the same benefit, but that depends very much on the context. Can you tolerate model errors? And they are unavoidable, so we have to live with them. And then you have to put mitigation in place. So if you know that your model is wrong, then you have to make sure that if it is wrong, that you can fix the mistake very quickly before it has an impact in the real world.
Okay, great. Alessio, anything you want to build on in terms of that one?
No, it's spot on from that level. I entirely agree. I don't think we can remain static. We need to adapt with a changing environment if the environment is changing. So it's all about monitoring performance. And once we detect we're moving away from the envelope, reconsider where we are, and with proper bias reasoning, rebuild environment, and in case change the model to the different working conditions.
Okay, great, thank you. Alessio, Rob, anything either one of you want to add to that particular discussion?
Yeah, I think, again, it comes back to this thing about organizations being able to remember things. And in this case, it's remembering what it is that defines the safe and the effective operation of the model once you've actually put it into production and it's left the hands of the data scientists, maybe. And so somehow you have to have a mechanism that you can transfer all of the relevant information to the people who are now the stakeholders for the model to make sure that they, A, know when something in the environment has changed that's going to make that model, say, become not profitable, and therefore be able to react to that. And I've forgotten what B was, but basically being able to have them in the position to know that if they're going to tweak any of the dials on this model, I remember now, let's say they change the incentive that's offered, that could push that model right into negative territory. So you've got to have a mechanism that makes it very clear to those people and keeps it present in their minds. These are the limits that I've got in terms of what I can do to this model.
Okay, great. And I meant Raoul earlier, and I said Alessio. I realize what I've done now. So, Raoul, you got your hand up as well. So.
Yeah, I think it's a really interesting topic, right? Because I would say traditionally we would think of data as being static. We train it and we're done. Whereas now we appreciate a bit more that we live in a fast world with new data. And there's a few challenges to consider. I think the one we're talking about is, we do need infrastructure to monitor and alert if something goes wrong. I would say that's probably maturity level 1, right? Which is great. We now know we've got a problem, but what are we going to do about it? So I think a lot of organizations are moving into maturity level 2, which is actually, we need some sort of automated infrastructure, which allows us to retrain a model, have an end-to-end pipeline. So when we've got a fix, it can be redeployed fairly quickly so we can address the problem. And this kind of practice is a bit nascent in machine learning, and people tend to call it ML ops. So it's the idea that actually, not only are we building models, but we have to build an operational infrastructure around it. And I think, Rob, you mentioned experiment tracking. So I think that's broadly would fit within the infrastructure, but I think also a way to deploy automatically changes. I think that's something that large organizations now are investing a bit more into, because if we are to react to a problem, we want to react quickly to address that problem. And that comes with some level of automation.
Mm-hmm. Okay, great, Raoul. And Detlef, you want to make a final comment on this topic?
Yeah, Rob mentioned that organizations need to develop a kind of a procedure and a memory for working with models. And there are industries that are very familiar with these kind of things, like aviation or medicine. And so when medicine is released and it's monitored, there are side effects, and the professionals learn from it, and then they might change the way the medicine is used and under which condition it is given to people. Or if there's an accident with an airplane, then the whole industry learns from this. There's very sophisticated analysis around this. And this is where we need to get to as well with data science and machine learning, to a well-established engineering discipline where we have methods that tell us how we're doing and how we can learn from mistakes. And also think about things like warranty and product safety and responsibility of bringing something into the market. And so if you buy a car and something goes wrong with the car, you have a warranty, and the manufacturer needs to make good on it. If you sell an AI model for use, then we have to think about how do we establish warranties and product safety and responsibility. Who's responsible? The person who uses the model, the person who sold the model, the person who has provided the data for the model, the person who has trained the model. So there's a complicated chain of responsibility that we have to work through and understand.
Cool, great, thanks. I know from some discussions that I've had with some insurance companies, they seem to be really struggling with, you talking about the productization of this. Who do you insure in an autonomous vehicle situation? Yep. Is it the owner of the car? Is it the people that made the car? Is it the people that did the software? Who? And I think as one example of that, they're really struggling with how they operationalize the advancements of AI into that particular area. There's a whole other day of topics we could discuss in that particular space. But I've also had one question come in from one of our people watching this, from Sanjay Kumar Singh. It says, how do you create a data ensemble without corrupting the real life data for analysis and research? Yeah, and so you were nodding positively, Detlef. It's a bad sign for me, so you're going to have to answer that one first.
I saw the question online. I wasn't quite sure where it's going to. So there's this process of selecting data that you want to use for your modeling. So this is kind of making sure you have a representative sample, for example. But the question is also mentioning security and apparently data privacy. So you also have to look at, am I allowed to use the data that I want to work with? So is it personal data, privacy, impact-related data? Then you have to check if legislation allows you to work with it. Do you have consent to work with this data? Who is allowed to see this data? And or who is allowed to see the results from you working with this data and creating models? These kind of things need to be looked at, and they are written down in legislation. In terms of security, you have to make sure that nobody gets access to the data who shouldn't have access to the data, and that can be a problem after you have built a model and you have released it into the wild, so to speak, because some models can be kind of probed for the data that you have used to build them. And so you might have something called data leakage out of models, which you need to look at afterwards. Another problem to get your head around and understand, is my model giving away secrets when I release it into the wild? So these are the kind of problem areas to look at in this space.
Okay, great. Alessio, you have any to add to that?
No, I agree with Detlef.
Okay. Raoul? I'm going to have to create some controversy here. I can see it coming. So, Raoul?
Have I inherited the controversy status now? No, I think that was a great answer. I would just add that you've got all those problems, but there are also solutions, right? So I think there is off-the-shelf like tools that would check for fairness or privacy kind of like concerns, looking at the data. So there's a bunch of tools available that you can add in your workflow to check for certain things, right? So it's not all the gloom, I would say. And I think there's quite a lot of research actually in this space. And there's lots of open source projects on GitHub available as well.
Okay, great. Rob?
Yeah, so I don't know if I'm going to be controversial now. Well, but first to develop on what Detlef said, I think in the real world, often getting data is like the key problem. Building the model once you've got it is relatively straightforward, or when you're building a solution can be relatively straightforward. And so you're usually operating under some constraints. So it's not unusual to find that the data set that you have is not ideal, but you've got to work with it in any case. And I think that's where a lot of problems then, particularly, they arise. And they're not necessarily problems that you should fix downstream, for example, by applying tools to mitigate fairness, for example. That might be part of the solution, but I think we need to be quite data skeptics, really, when we're going through the process of building models, and make sure that we're asking the questions up front and identifying the risks that might be inherent in that data set, and that then tells us what we need to watch out for downstream. So if we know that our data, I'm going to pick an example that's known in the media, the Amazon's CV screening tool that was developed and maybe used or not used, I don't know. But there are scenarios like that where you can reasonably now look and say, well, I think that data is going to embed historical behavior that perhaps isn't what we actually want in our model. So rather than fixing that downstream with a fairness or bias assessment, you need to think about, is that data actually the right data to be using for the problem at all? So I think the tools maybe have a part to play, but you really need to understand what they do, particularly in the context of bias and fairness, and make sure that they're actually doing something useful.
Okay, great, thanks. We've had another question here about is there any work being done on multimodal models to enable or accommodate the complexity of the real world? So I'm assuming this is multiple models aimed at a common issue or common question from that perspective. So can you give me some insight in terms of what work you're aware of is going on in that space? And Alessio, can I start with you with that one, please?
We're not working on that directly. I'm aware that there is work going on. I'm not sure whether the person is asking about models in which there's fusion components from different potential inputs. So that is quite common in perception systems where you are perhaps putting together a LiDAR system together with an automatic vision systems, and you want to reconcile the different modality of inputs that are coming in and reconcile them and trying to build a model which is making sense of the different inputs. That is, absolutely common. And then the challenge becomes, ensuring that these fusion elements are actually working correctly. If that is, the spirit of the question, absolutely yes, and it poses challenges, and it's a very hot research topic.
Great. Raoul, do you have anything to add to that?
Well, I think I'll leave that to Professor Alessio. I think it's an interesting topic. I guess, things like joining images and text and be able to understand when one influences the other. I think that's an interesting topic, but I'm not doing research in this space personally.
Okay, great. Detlef, do you want to?
Yeah, there's several aspects to this, right? Alessio pointed to things like autonomous cars, which is where you have different sensors recognizing different things, and you have to combine this to a picture of the traffic and where's the road and where the pedestrians and so on. So that's one challenge. Is like things like you used to call sensor fusion, maybe, and there are other things where you want a model that can not just say yes or no, churn or no churn, cat or dog, where you have something that can recognize a variety of things that is much more difficult than just a binary classifier, and much more difficult to learn. There's also this idea of ensemble models, and this is where you build different types of models that you then combine. They all try to predict or classify the same thing, but it's like a group of experts, and you get multiple opinions, and then you go with kind of the average or the majority decision, which is a common thing that even in computer science was used for, let's say, the Apollo missions. They had 3 computers, and if they would disagree, they go with a majority decision.
Okay, great, thanks. So let me change tack slightly here, and this is more about skills and knowledge and such. So if people had a better basic understanding of data science, would your job as data scientist be easier? All right, and Raoul, can I start with you on that one?
I mean, the answer absolutely yes. Especially, I think there was a current presentation that we program with data now, so 99% is the data. Then there's a bit of a mulling afterwards. I think all data scientists, all researchers, they would love to have more cleaned up, accurate data. So actually having the skills to do the dirty stuff, right? Like loading the CSV, figure out missing values, converting the right formats, just simple things like that, just helps accelerate the process of innovation. If you don't have that, you're going to get your data scientists being involved with that process. So it might be it might be okay, but it's not the first skill set you want them to use in the first place. So yeah, I think getting those skills to do a bit of data processing, cleaning, to create those assets that data scientists can work on, I think it's definitely beneficial to the business.
Okay, great, thanks. Alessio, do you have a view on that particular issue?
I have used pretty much on everything. So my view on this is that what I'm seeing is a lot of people wanting to use particular technology just because they feel they have to. And conversely, I'm seeing some people who could be using some of the technology and are extremely reluctant to. So I think the answer to your question is absolutely yes. Having a better understanding of the qualities of some of the technology, including AI, including data science, and so on, and having equally an appreciation of the potential difficulties would make these decisions a lot easier. So I think investment in education and self-learning in this aspect would bring back a considerable benefits on both sides. Okay.
Okay, great. Detlef, Rob,
Yeah.
view?
I mean, it would help if everybody would be more data literate. And it's definitely something we have to strive for, because the technology that we're seeing developing with AI and machine learning is going to impact all of our lives. And that means people need to understand what that is, how that works. And that means they need to get an appreciation of the kind of raw material this stuff is being created from, which is data, and what that means. In business context, you often find that people have kind of the expectation that these things can perform miracles, and this is also driven by still a lot of hype in the industry that hopefully will level off in the coming years. But a better understanding of what you can do with data and what machine learning and data science can achieve would certainly help in terms of realistic expectations in businesses, and also in appreciating the value of data and making sure it's collected properly and maintained properly, and that there's some investment in this kind of raw material that we need in order to work with in data science and machine learning.
Okay, great. Rob?
Yeah, so as a direct answer to the question, a sort of tentative yes, as long as sort of knowledge of data science translates, as Detlef said, into a more realistic understanding of what's possible and what that's founded on, you know, what that depends on. But also on I think the thing about the value of data is really key. And I'd go a little bit further on that. I'd say I'm inclined to the view that what we actually need is an economics of data, right? We actually need a much more rigorous framework for understanding the value of the data that organizations have or they've got access to, and how they can translate that into business value. Because I think without that, we're just left with a sort of hand-waving arguments that, you know, data quality is important and it's important to be able to access data. It's very hard to build a business case based on that to actually go and fix some of the problems upstream in terms of your data infrastructure and the plumbing that's available to move data around and so on. So I'd argue for a much more rigorous foundation that's needed to enable all of that.
Okay, fascinating. Well, that kind of leads on to the next question about, should it be taught in schools? And if it is to be taught in schools, and I'm not talking, you know, university level here, I'm talking, you know, high school, maybe even middle school level and below at a very basic level. Should it be taught there, and how would we go about achieving that? Because I'll be totally honest with you, the minute you mention data science to the general public, they kind of go, what? Or, you know, what is that? And they're not that excited about it. How do we get them excited about this kind of stuff? And once again, I'll go back to the original schools question. So, Raoul, since you mentioned the skills issue, I'm sure you got a view on this one.
Yeah, it's a fascinating question. I think we all wish we could teach more at schools in really exciting topics. I think there's probably constraints around time, budget available, and other subjects, right? So I don't want to, I guess, cannibalize that discussion. From my perspective, I think maths, generally I find maths useful, right? So teaching math statistics at school, that's already happening. I think that's great. So building understanding of how we can quantify certain decisions, I think that's useful. Most schools in UK are teaching coding now, so that enables like children to get understanding of digital technology, experiments, try things out, get excited about that. So I think in UK is probably leading the way as far as computer science into school is related. If we talk about data, I think it's probably going to fit in either the maths and stats box, or it's going to fit into the computer science box, I think. Now, I think it's good to teach kids not just technical skills, but actually challenge how things work. So actually, you know, I think we had an example of face recognition, why it might fail. Maybe because of bias in the data, maybe because of some algorithm failures. I think being able to challenge why certain solutions are not effective is a useful skill set I see when you take a job, right? So that helps you become more employable in a team. But I personally don't think we need to have a full data literacy curriculum into schools. I don't think that's necessary, but just appreciation of the topics. It's the world we live in, so yeah, that sounds useful.
Okay, great. Alessio, any comments on that?
Yeah, a difficult one. I'm not sure about data science as such, but I think that there is definitely a need for getting more proficiency in topics such as probability and statistics that we presently have. General topics such as decision making and appreciating numbers in the context of other numbers. I think we've seen some of that also in the past 2 years and some of the problems we have in that space in collective decision making. So I'm not sure whether, teaching data augmentation to children is particularly useful. They could do it in lab classes, they already do Python for sure. But I think that we desperately need a better understanding of probabilities, better understanding of statistics, and how that is then translated into computer system and decision making. I think that is something that should definitely feature in definitely secondary school.
Yeah. Yeah, if Blaze is still online, I'm sure he would have loved that comment, given where he was coming from earlier on with the statistics. So, Detlef, Rob, any comments on that?
Yeah, I think very much lined up with the other two in terms of it's tempting if you're excited by data science and it's the world you live in to think that you should teach everybody that, and obviously you then displace other things from the curriculum, and it's a finite capacity, so I think you have to think very carefully about what it is you're trying to achieve. But I think Alessio's hit the nail on the head. I think there's some fundamentals there that we could usefully put into the curriculum around, things like sort of understanding probability and critical thinking and reasoning skills and those sorts of things, which then, hopefully give children a good foundation to build on if they do want to go down that path. Equally, I think we need to think, are there things that we want to introduce into the curriculum to help demystify stuff that otherwise people are just going to be fooled by, and we want to equip them to be critical thinkers and to see through the hype in the world around them.
Great. So it's about teaching those basic skills. I mean, I know BT has an educational outreach program that talks about critical thinking. They call it computational thinking, and they explain what algorithms are and how they work and so forth. And we start that at like year 3.
Yeah.
And such. And I just say, well, I think what I'm hearing is most of you are advocating that kind of approach. You don't have to call it data science, but those underlying skill sets that would work in that area. Great. Great, guys. Once again, thank you all very much. I'm afraid we've timed out on this particular panel session. So Raoul, Alessio, Rob, Detlef, thank you very much for your insights and your presentation. Also, thank you to the other presenters that we had earlier on today as well.